So the main important thing, guys, you want to remember about this is when you're adding and subtracting fractions, you've got to have common denominators. All right? And identifying common denominators for fractions when we're dealing with integers in the numerator and denominator is not so bad, because we know the factors of 3, 6, 9, 12, 15, 18, 21, the factors of 4, 4, 8, 12, 16. So even if we're looking at our phone, we can say that, well, I know that the smallest number, which we call the LCD, that both 3 and 4 divide into is 12, right? Also called like the least common multiple, right? And so since that is the smallest term, what we need to do to add these together is we need to be able to get our denominator to be the same. And we want to use that least common multiple, or in this case called the least common denominator. So all we're going to do is multiply our 3 by 4 to make it 12. Now remember, to keep equivalent fractions, we have to do that on the numerator and the denominator. So therefore, we get 8 over 12 plus 9 over 12. And that equals 17 over 12. Right? It's a little extra step. People don't really like it and whatever else, but it works. So in Algebra 2, we introduced you the same exact idea, but then instead of as integers in the numerator and the denominator, we gave you algebraic expressions. So then we had to come think to ourselves and say, all right, is this something completely different, or is this very much related to what we just did? And the answer is it's the exact same process as what you guys already know from 6th grade. Now the problem is, to find the common denominator of 3 and 4 is rather easy, as I mentioned. Can we just like list off all the multiples of x plus 3? It's not like as intuitive to us, right? So then, but we know from our polynomials unit, x plus 3 does divide into other polynomials, right? Right? We practice dividing something into something else and getting a remainder of 0. We know that x plus 3 divides into something else, right? And gives us 0. And again, we can actually know what a multiple is. One of the easiest multiples is the product of these two. Because if I did this times this, I would get x squared plus 7x plus 12, right? Does x plus 3 divide evenly into that? Yeah, it divides into that x plus 4 times. It's just like this. Does 3 divide into 12? 4 times, right? So the process that we got here was multiplying our two denominators. The easiest way to find a common denominator over here is, again, just going to be multiplying our two denominators. Now, that's not always going to be the case, which I'll explain in the next example. But for here, guys, our LCD is just going to be the product of our two denominators. What's the answer? Well, we got a little work to do first. So what we have to do is multiply each fraction by the other product to get to that common denominator. Let me actually write this down here. I want to keep that. OK, so now I have 2 times x plus 4 all over x plus 4 times x minus 3, or x plus 3, sorry, plus 3 times x plus 3 all over x plus 4 times x plus 3. So do you guys see how this process is basically like exactly the same? Now I have common denominators. So now I just combine the numerators. And again, the only difference here is we're just going to ask you guys to do a little bit more algebra. So I need to apply distributive property and then combine like terms. Now I can combine these, though, all under the same fraction. So 2x plus 8 plus 3x plus 9 all over x plus 4 times x plus 3. On these problems, I will be asking you guys to simplify the numerator. So that would be 5x plus 17 all over x plus 4 and x plus 3. And then do we have some values where x cannot be defined? -4 and -3. OK? Now, we don't want to get caught, though, into always multiplying, which I'll show you guys next.